Okay. I think I made it. OBS always lags when I'm in the game with the shader. I'm not surprised. Long time coming though. But we're here now. Very cool. Alright. I'll be in game first a little bit. And just show some stuff. Just probably jump around a few worlds so people can get an idea of where we are currently with the state of things. And then probably if I'm in the right headspace for it, maybe work on the shader pack a little bit. But this is mostly kind of a Q&A thing that I wanted to do for people to see and to hear what I have to say about things. Because yeah, I've been very busy. I haven't worked on the pack nearly as much as I have like about a year ago. This has been a long project already. I mean, I started this when I was like 14 or yeah, 14 probably. 2021 was when this all started. And a lot of stuff has changed in the time since then. So the code base in places is very messy and not the way that I would handle it now, but oh well. What am I gonna do about it, right? Unless I rewrite the whole pack, all I can do is just clean it up as best as I can. But there are some fundamental issues with the way that I started writing this pack that I now only noticed after like ages basically, that I will have to address at some point, surely. But yeah, for now this all works pretty well. And yeah, I mean, what have I worked on recently? Mostly GI related things. Global illumination, obviously, being one of the main aspects of the shader pack. Of course, development effort is gonna go into that a lot. And it's still not in the best place that it could be in. What I mean by that is, as you can see, especially indoors, it's still very noisy. And this is due to two reasons. One being that the way I currently sample global illumination things is very suboptimal. Like, it's the most naive way you could do it, basically. And the other is just that my temporal filter is a bit whack still. I mean, if I move too much, it will just reject a lot of the samples near me. You can see this here when I'm on the right side here. It just rejects all of them, which wouldn't be necessary. And then my variance estimation is kind of off sometimes, especially for early samples. It's not great yet. But if you just stand and wait for the filter to do its thing, it doesn't lose the detail much, so that's pretty good. Right, if you just stand here, still looks a bit splotchy, but that will be also mostly resolved by just better sampling. So there we go. But yeah. I'm also noticing the delay on my stream is pretty bad, so answering questions might take a while. Like, looks like 10-20-ish seconds right now. But yeah. So yeah, normal detail is being preserved, but that means obviously that the filter has a much harder time. And that will be fixed using spherical harmonics at some point, but it's not really a priority when the sampling itself isn't great yet. So there's that. Honestly, most of the efforts recently were more related to the internal structure of the pack rather than the visual aspect of it. Because getting the internal things right will allow me to just optimize better, essentially. Right. So this looks nice, right? You got all the normal detail preserved. The indirect shadows are pretty good as well. This looks better at midnight. Then you get the actual indirect shadows. They're more present this way. Yeah. So there it is. Yeah, I will basically now just go through the code base, just do some work. If anybody has any questions, they can, of course, ask them. I'll try to do my best and answer them. And yeah. So there it is. So what do we got here? Open changed files, yes please. Right. So I think the first thing for me would be fixing an issue in the water. There's this really weird issue. Which partly it fixed an issue and then it introduced a new one. Usually that's how it is. Oh yay. Minecraft crashed. That's wonderful. What a wonderful thing. Just start that up. But yeah. So basically has something to do with shadow comp here. There it is. I think now it should be back. Yep. All right. No. Okay. Still crashing. Okay, maybe it's something to do with the world. I will see. I'll check that later. I will go into a different one in that case. Right. So as you can see, lots of files already. Kind of going insane at this point. These will probably be able to get rid of completely. Water mask we don't need anymore. These shadow map parameters also. So yeah, let's clean that up. Alright, so we're back in the game. I guess then I will go into... Oh, screw it. I'll just go into a different world. I'll make this... don't want to make this more complicated than it needs to be. We just call it stream 27th, whatever. Yes, do allow cheats, please. Please do allow cheats. Thank you. There we go. Right. So we have this issue of essentially, right, if we go far enough, deep enough here, you can see this is tinted blue, and of course it is, it needs to be, right? Because the full volume should be absorbing the light until it gets here. And this is currently done by simply multiplying the shadow color. Right, so if I remove this, you will see, if I get close enough, this is just pure blend gray now. So if we put that back, and we're blue again, right? And so I'm baking this multiplier into the shadow color, but the shadow color also contains the caustics in this case, right? Like these funky little lines on the bottom, on the ground here. That's also in the shadow color. And the volume uses that shadow color to basically say how bright that part of the volume is. And this blueness factor, this extinction factor, shouldn't influence the volume because that has its own like factor that depends on how deep it is. Hi Lear, how you doing? So yeah, it shouldn't have that baked in to the same thing. But it's fine for the ground, right? For the ground it's okay, just not for anything else. So I'm looking of a way to essentially pack both values into one buffer so that we can have the caustics and this other multiplier separately. And you know, this buffer is being used for any shadow color. Make that false so we don't get this weird thing happening. This is still like a subsurface issue that is physically correct. Like on a physical level it makes sense that it happens, but it just doesn't work when the geometry is quite literally non-existent. It's just thin. Anyways, going back to this issue. Yeah, essentially what I'll do is I'll pack the shadow color and the caustics separately. Sorry, no, the the caustics and the shadow color are basically the same thing, and then I'll pack the extinction factor separately. And I know that the extinction factor is only in the range of 0 to 1, right? And shadow color normally is 2, but the caustics aren't, essentially. So there's that. So what I'll do first, I guess, we do need to keep this at 0, I believe, because otherwise the shadows are basically black. They don't let any light through. So this is behaving like it should. Right. Just like half the brightness it would normally have. This is just fully dark, it doesn't let any light through. And I guess the water volume doesn't account for that, but why would it? I mean, it makes sense. So yeah, 0 anyway. Now I've actually, if anybody notices, I did disable cumulus clouds for streaming because they look great. The only problem being that they're not very well optimized currently yet, and they might make the performance look a lot worse than it actually is. These are very like work in progress. So, yep, this is Prism. This is Prism that I have been working on for half a decade almost, actually. Yeah. It's a lot more realistic with material rendering than most packs, but the GI just currently doesn't look very great. But yeah. Also, it has a custom tone map, which is pretty neat. It's pretty cool. Right? But these are the clouds. They do really fill out this the sky very nicely, in my opinion. And yeah. If you see like a noisiness in the clouds, that will be taken care of partially by just accumulation of the clouds themselves. These will be downsampled and then upscaled, and then accumulated also. And then we have TAA as well, which will make these look better and perform better. just a matter of time until I get around to implementing all of that. So yeah, if you stand still, like quite literally as soon as you stand still, everything converges, like within a matter of like a few frames. It's just getting to that point which is still the issue, because at the slightest movement it's very like responsive, and that is partly an issue actually. But yes, I will disable them again because they do not perform amazingly right now, to be fully honest. So get rid of those. I rendered them twice, once for the kind of sky map that I'm using in water reflections and like terrain reflections when I get around to those. And then, of course, for the sky itself as well. So yeah, anyway. We got this issue in Shadow Comp still. This is how the volume should look, right? So it looks a bit less bluish. This is how it should look. But then, of course, down here it's not tinted anymore. So that's what we're trying to fix, essentially. We got this shadow color. And I don't exactly know. So this is where we're calculating the caustics here. And then Shadow Comp runs after this. So this is now in the range of like 0 to technically infinity, but caustics don't really go that high up. They go high, but not that high. So what I'll probably do is pack those into 2 parts of the vector, and then pack the extinction into the 3rd component. And I might only do that encoding when the water mask is active, essentially. So I don't have to change encoding logic for any other parts of the shader pack. Now, how do I get access to that? That's the thing. So we got the material ID here. Yeah, got the material ID in here. We could pass the material ID into the alpha channel and then set it to 0 as soon as we've used it in the shadow comp. That could be a way to do it. Right, because here we're still... Here we could... I think we could set anything. I don't think it would matter because then in shadow comp we set it to 0 anyway. So if we take this and convert that to float, doesn't change anything, right? Whoops. Then in shadow comp, what we can do is just... I'll read this as a vec4 instead. Shadow color is 0. Oh. And then shadow color.rgb. Nope. Oh wait, actually yes. Like that. Dot RGB. And then nope. Copilot is annoying me. I could actually, you know what? Let me just disable Copilot for the time being. Disable completions, yes please. Right, and then let's see. Let's try color 0.a. We'll make that into an int, or yeah, I guess. It's always a bit tricky with those. I hope we don't get any rounding errors here. Show color 0.rgb equals, and let's make it just red to see that this would work in theory. Right. There we go. So now all other shadows should be left untouched as they are. If we remove this, everything should be red in theory. Or everything that is a colored shadow, so stained glass will be all red now technically. Yeah, there it is. Right. Now if we put this back in there, it's not. Yeah. Cool. Very cool. So we got that. And then now if it's water, we want to pack it differently. So we got water extinction and the shadow color. Or we could do the shadow delta as well. Let me think about what makes most sense in this case here. So custom encoding logic. Yay. The water looks pretty good. It's just missing that final, like, yeah. As you can see, this is way too bright looking now. We're so deep down and it's still so bright. Doesn't make any sense. Right. Yeah, no, it's in, yeah, it's in a 0 to 1 range, so we can probably pack it that way. So I believe it was I, there we go. Naval. Is it about this? Yes? Oh yeah, okay. So it is responsive. I was about to say, that's weird. Right. So shadow color 0, let's see. Buffer attributes. Shadow color 0 format. RGB 16F buffer. Create an encoding for a RGBA 16F buffer at x2. What is that? No, 1vec3. 1vec3 and 1 float in range of 0 to 1 into a vec3. Here it is. So it really doesn't need my code for this as a... Oh no, this... No. Pack the data into a vec3 using bit logic. See, this is the thing with like code completion stuff and AI tools. It's like they always like try to make it the easiest possible for them. So sometimes you gotta be like, nah. Oh, no, no, no. Nah. That's definitely not... That's definitely unnecessary. Okay. I guess Copilot isn't that great for this kind of stuff. I've never tried it before, but... Well then. No Copilot today, huh? There it is. Alright. Mm-hmm. Essentially, we're just looking to quantize the data into a buffer using fewer bits. So we will have precision loss, but it's not that big of an issue for caustics or shadow color. So that's fine. All right. So of course we'll have this whole thing going on. Encoding. I believe bit quantization is the terminology for what we're trying to do here. We could, of course, use up another buffer, but that's a bit excessive just for the water volume. Or what, I mean, the caustics are just one float that has a basically unconstrained range. So, because we have an RGB 16F buffer, and we have three, like, free slots, basically. Like, we have RGB and A that we can use. And we want to pack, we could pack the shadow color and the extinction into one. Then it's for sure, then like it's a Vec 3 that is in the range of 0 to 1. And then we would have only one float that would need 16-bit precision, essentially. Right. We want to pack one Vec 3 that is in the range of 0 to 1. And one float with the range of 0 to technically infinity. So yeah, that's basically it. But in the meantime, let's see. There's a lot of things that are just left in my code for me to look at. So let's go through those. Find in files, and then it was like a to-do. And I left a bunch of them here for me. Let's just go through those and see if these are still even relevant. Ozone coefficients look off when viewed from space. Double check the data. I think I did that. I believe I did that, because now we just take a look at our atmosphere. I think this looks pretty alright. The clouds still, they're too visible from up here, because essentially I just don't have any extinction, like they don't interact with the atmosphere yet. They're just their own thing. Right, I forgot how this worked. There it is. This is very bright. This is kind of a auto exposure issue currently. Yeah. Wow. Yeah. That's the planet surface. Doesn't look that nice at high exposures though. It needs to be kind of dim. So, yeah. Generally, this time of day is not fleshed out yet. I mean, you can tell, right? Can even start, like, this gets kind of desaturated, so you can kind of start seeing how the Purkinje shift starts kicking in. And it is a fully, like a fully physically based Purkinje shift too. Oh. Something failed here. Oh, that's because did I save this? No. It should be good. Yeah, there you go. Yeah, desaturated. As it is in real life. And you can still see some color poking through, like here on the sunflowers. Did I really just forget the name sunflowers? I think I did. I think I forgot what these were called. Sunflowers, obviously. And yeah, so you can definitely see that they're yellow here, especially like if you look from the angle. This has something to do with the RDF of the well, subsurface, because this is a subsurface object, right? And subsurface materials are usually brighter when viewed from an angle, even more so than normal materials. So this, right, is more desaturated, and as you go to the angle, it gets more and more yellow. That's just, yeah, those two effects interacting with each other, I suppose. But yeah. That's also the reason, if you look at the Disney BRDF, they have an extra divide in the denominator to create this kind of effect. And mine is similar, I believe they fundamentally they're based on the same principle. Just that mine is energy conserving and just overall a bit more thought out than the Disney one. But yeah, you can see it's not all gray, right? It's not all gray. There's color where they're supposed to be. These colors are kind of, these flowers are kind of pink still. And the lava obviously is not gray. And I'll never want to see gray lava in a shader pack. That would be horrible. But yeah. So these look good, right? Still rosy, still pink. Very nice. Not too much of it. Like, I think it's just the right amount. I've actually tried turning down the Purkinje shift, and anything else than the physically based parameters looks kind of off. To me, at least. Because it doesn't get bluer just by turning off the desaturation, because midnight is not blue actually. It's more of it's also related to Purkinje shift, but turning off Purkinje shift doesn't make things blue. So yeah, I haven't found a proper way to tint the night blue with physical, like using a physical model, because this is using a physical model, right? This desaturation is using a physical model, and I don't want to ditch the physical basedness just because I want my nights to be blue. That would not feel right. But yes. So yeah. Essentially, it seems I will change the way that I pack my shadow color. Let me just go back to the noon time here. Looks a lot nicer. Instead of doing caustics and shadow color in one, I will do shadow color and water extinction in one, and then I'll do caustics in a separate thing. So let me just check how we would do that here. So here we're just setting it equals to the caustics. We're not even doing anything else here. By doing that, we are overwriting the watercolor. So we actually don't... Okay. Let me see something here really quickly. Right, we got this beautiful stained glass. Put this underwater. Don't mind the actual glass rendering, but this is not casting a shadow anymore. Right? That's terrible. Why would we ever do that? And why is this returning a Vec3? I'm going insane. I am going insane. Okay, so this can be a float. Why pass around more data than I need to, right? So, caustics. That's a float now. And I want to completions, disable completions. There we go. So, there. Caustics. It's a float. It's not a Vec3. It's a float. Now, shadow color. Okay. So we got material ID in the caustics, and we got the shadow color now. Ideally, I'd just calculate the caustics in shadow comp. Right, that would solve a lot of issues, because I wouldn't have to pass it off, pass it to anywhere. Yeah. But yeah, so let's fix the other stuff first, though. I mean, we got shadow color here, so we can make this shadow color.rgb. Multiply this by the shadow, by the, whoops. What's happening now? Oh god. Oh, I think I see what's happening here. There it is. Now we're getting our stained glass back. Okay, so this has something to do with transparency rendering that I probably won't be able to fix now. Remove this. Okay. Okay, so that's a separate issue. Never mind that. So it'll be either caustics or the shadow color. And then and then we got the water extinction as well. But I honestly don't mind reserving a spot for the caustics. That's not something I would never want to do. So yeah, caustics. Yeah, this is a float. I mean, this is, yeah, it's just a float. Let's see here. So we got, yeah. Okay, hold on. This is kind of a mindfuck right now. This is kind of confusing. So when it's water, we don't have any shadow color, because when essentially when the block is above water, it doesn't count as water at all anymore, because there's no caustics, right? So then it's just caustics and the extinction. So what we actually need is a way to pack the extinction into a vec2, and that's it, as far as I'm concerned. Right? As far as I'm concerned, that's kind of it. So, alright. Let's make this just C and then 2 empty slots, right? And this was where we will pack the extinction. And then in the water, I don't know if we need to do it. Okay. Now we need to fix it both in the volume and in the shadows. So this would be, okay, let's do shadows first. I hope this is gonna be relatively straightforward. We got the shadow color, right? If we do RRR here, this is gonna fix it, right? That's that, but then, you know, this doesn't work anymore. So we need some way to know. I guess we might need the we do need some way to know if it's water that we're sampling or not. So shadow comp is running. So what if we what if you took this and made it -1 or anything negative, and then we just forwarded shadow color? Because then what would happen in the shadows is if so it would be like 4 shadow text, shadow text 0 tap, I guess, then, right? And we do this, and then if dot A is lower than 0, then or higher than 0, we do this RGB, otherwise, right? Boom. This should do it. No? Star. But it's not. Oh wait, it's shadow color. This is what we need to. My bad. This is what we doing. Yeah. No. So it's thinking this is now always negative? I don't get it. Oh, okay. No, I think I know what's happening. This is probably some kind of precision issue. So let's make this minus 0.5. No, okay. Now we're back to where we were. Okay. Is it this now that's not working? We're still forwarding material ID, so I think it should be fine. And then we got this here. Let's go back here and remove all this. There it is. Okay. In theory, my water should be red now, but it's not. So that's weird. Surely I don't have to turn this up. Okay, now it's not doing anything anymore. What did I change? Didn't change anything here anymore except for this, but that's unrelated. Alright. Got caustics, which are still fine. We do this. Okay, this is really odd. I mean, let's nope. Deferred. No. Water. Huh. Shadow. If I remove this conditional, will it change something though? No. What the hell? I am getting so confused right now. Shadow color right. Vertex 0, which is shadow color by the way in this case here. If I don't write anything. Oh, okay, now it's working. Like now it's like changing something at least. So okay, so I'm not going insane. Hmm. There it is. Now stained glass should still have the same correct colors, right? So this should be blue. Yay, there we go. Oh man. Okay, well. You got red water now, that's pretty cool. We see a water volume. Says simple shadow. Replace that with just RRR. Did I say this? Shadow color. Yeah. So now we got the volume is correct now. The bottom is red. Getting somewhere. Getting somewhere. So all right. There's something I do wonder. Take stained glass now. Hold up. Was that different before? Okay, that's interesting. Okay, so it did do all that. Alright. Fair enough, so I guess we need a way to differentiate between what is water volume and what is not. But for now, we'll just make this that. Cool. All right. So yeah. You could of course also just pass in the distance, but then that's... It is a 16F buffer now that I think about it. That's probably fine. I only need it once for the terrain, essentially. So... Where's my red thing here? Go, wait. RGB. There it is. I don't think this is something that anybody would notice, to be honest. This tinting of the stained glass through the water volume. Probably unnoticeable. Probably. Wouldn't be noticed by many, I don't think so. Alright. So... Shadow comp. I might leave this problem for future me. I don't think it's the best thing to work on stream, to be honest. This feels very more, or I guess I'm making it difficult for myself because I don't want to use up more buffer space. So doing this now might not be the best call. Where's that stained glass? Oh, it's right here. Yeah, also every translucent is currently being rendered like water. That's another thing. But I do have translucency rendering in place, like it's a thing. It's just not engaged right now. Okay, let's see what else we could work on, or I could work on. So a radiance cache would be a bit of a big thing again. Sun is likely too bright. Calculate air number density. Oh, not even using those anymore. I don't think. Yeah, no, I don't think I need those at all, actually. Stopped using those a long time ago. And these kind of seem off as well. Or maybe I'm yeah, okay, no, I do use those, never mind. But I don't use these anymore. Not much of a change, honestly. That looks nice. That looks nice. Assumes moon albedo of 1. I think that's fair. Guess. It's just a ratio. That makes sense. Do I not have a geometric normal output for this yet? Hit G normal, I did, right? Oh no. I did not. Interesting. Hit normal. Hit G normal. Wow, so I don't have a geometric normal output for my voxel yet. That should be simple enough, I think. Let me see. I don't even think I would need to encode that, to be honest. Where is it? Where's my decode and logic at? Util? Voxelization. Decode. No. Util. There it is. Decode. Get voxel tvn. Where was it that I... Hold on. Where was my to-do of the... Here. Raytrace.glso. Interesting. Okay. Get voxel material. Then... Where's that? That's in decode voxel material, I'm guessing. Decode material. Get voxel TBN. Normalize TBN. So the TBN here, this should be, wait. Okay. So this is literally probably what I'm looking for. I'm not passing this on, so I'll make an in-out like 3G normal. Excuse me. Yeah, and I guess G normal then will just be the TBN at the last position. So 2, because we start at 0, so 0, 1, 2, right? G normal, big 3, G normal. There we go. And then wherever we use this, we need to account for that, obviously. Which is just here, it seems. And then hit G normal. I think that should do it. In theory, of course. Always in theory. Let me just get rid of my water waves for a minute. So, actually, that would be in... What would that be? Composite? I think so. Composite. Scroll, scroll, scroll. I think I already passed it. Yeah. So, all of this, I guess. Oh wait, no, all of this is using refracted chord now, so I need to leave this be. Yeah, there you go. Okay, let's just check on our... Oh, okay. So maybe G normal wasn't right. And maybe this didn't all work like I was imagining it to. Let's I mean, just make it equal to normal. Doesn't look right either. Something's fishy going on. Something weird is going on here. Get back to how it was here, and then in here, let's just pretend like G normal is the hit normal again, I guess. Wow, okay. Something's not right here. Definitely not right. Confusing. These look mostly fine. Why ain't you looking alright? Alright, let's see what this could be caused by. So, files. So this is all being done in composite. Yeah. Again, yeah, that would have been weird. Of course they don't. Calculate environment reflection. There it is. Okay, let's make environment reflection equal to... Let's see. What could we do here? Do the hit normal. This will probably be dark. Yeah. Let's make this sun intensity. There it is. Now they are. Now they're here. Okay. So these don't look wrong to me. They... Yeah. These look fine. So let's then check on G normal. look fine as well to me. So we can confirm that I did in fact do that to do, so we can remove this. And then, but we apparently we found something else to work on, so that's good. um So it is not the normals. And to be fair, that would have very much surprised me. Then it must be in here somewhere. How about we return... Or no, what is it? Yeah. Environment reflection equals... light color times n.l, for example. Okay, so that's working. Well, let's then deconstruct this, right? So let's have the albedo first. Maybe, right? Not super sure. Let's make it light color times atmospheric throughput. Okay, that's good. Then next up, let's look how diffuse is looking. Okay, so diffuse is not the problem. I have a feeling that it's about to, like, that it's about shadows, but let's see. Yep, there it is. Lovely, lovely, lovely stuff. Shadows. What could possibly be going wrong here? I wonder. Is it the shadow bias, perhaps? Okay, now they're just completely gone. Wow, okay. We remove the shadow bias. It's better for some reason. That's also concerning. Was it? Okay. I did change something in the shadows here. Not the shadows, though. Shadows up with a S. There. This is what I changed. Oh, okay. Wow. There it is, I guess. Hold on. Maybe that was it. Yeah. That was all there was to it. Wow. I mean, sure, I guess. Yeah, I think the next big thing would probably be to do a better ambient skylight approximation for water and the clouds. Probably be the easier thing to do out of all the things, you know. So I might just do that. But first, let's look how this see how this looks with Actually, these look like they don't have a lot of specular highlight here. Specular. If I remove this, will I see a difference? I don't know. I genuinely don't know. I don't really see much of a difference. Maybe they're at the grazing angles over there. Nope. Really don't see much of a difference here. If I make it display this, maybe? Okay, so it is there, but it's just very faint for some reason. Maybe it's too faint. I have a feeling that it is, but I might also be wrong on that. Yeah. That's getting multiplied by all the right things. Actually, no, it's not. It's getting multiplied by albedo as well. That's obviously wrong. What does need to be multiplied by albedo? The ambient and the emission. Okay, so let's... So this needs to be in here. Let's just get rid of specular for a minute. There. And then... Wow. I mean, everything needs to be multiplied by light color. That's just how it is. Actually, why don't I go into here? Do it in multiple parts there as well. I guess I'll do it in multiple parts here as well then. So that's that. One thing can be... So we got diffuse, shadow, SSS, and ambient here. And this all needs to be also multiplied by the atmospheric throughput, except for the ambient, so that's good. And then what we're missing still is the emission, specular, that needs to be multiplied by light color and atmospheric throughput as well. I believe that's it. Emission there. Let's check how this looks then. Okay, that's too much. Is this already multiplied by light color? No. Emission. Okay, so it's apparently it's an issue here already. Light color times this. Light color times... Can't be light color. Come on. What'd I do, man? Let's go back. Just take specular out of the equation for a minute. Right. And then... Oh, was this like some weird value before? I hope not. Anyway. So, multiply both of these. I think that's it. You know, that looks a lot more like it. Yeah. Looks a lot better. Yeah, I think there it is. All right, let's see if we can somehow improve this formatting wise, things of that nature. Is the stream still running? I'm not fully sure. Think so, right? I think the delay is ungodly. Something like that. I don't know. Because my streaming service doesn't really catch up very well right now, it seems. But oh well. That's fine. Okay. Yeah, this looks a lot better, as I said. Now, everything except emission is getting and ambient is getting multiplied by the atmospheric throughput. Ambient is only albedo and light color. Let's get that out of here. Everything's being multiplied by light color except emission, so environment reflection equals, and then we got emission, and then plus light color times, and then we have this part. What was ambient be multiplied by? Also, light color and albedo is correct. So that, and then ambient. And then plus diffuse times shadow plus SSS. That's its own thing, kind of. So that's not being multiplied by albedo and light color. But this should also be multiplied by the atmospheric throughput, yeah. Oh well. I think it's fair to treat these separately. Like, what am I gonna do about it? You know what I mean? So specula, and then shadow times atmospheric throughput. Very long line. Guess that's how it is now. I think that should be good. No. Hmm. Hmm. No, I'll just keep it like that. Hmm. Don't think I need that part. I don't need that either, I believe. Yeah, no, there's no additions in there. Probably good that way. Oh, it's not. Huh. Light color. I'm getting all very confused right now. Hmm. If I remove this. Okay. That's pretty bright. Remove ambient. Is that the issue? Oh, ambient it doesn't need that. The light color. Really? Okay. And I guess, yeah, I guess it makes sense in a way. So, well then what does it need? Just needs albedo. No. So this can go in here. And this can just be added. There it is. Now, does specular look correct? Sure does now, right? Yeah, well, let's double check again. Shadow, light, color, atmospherics, throughput. Should be up. Yeah. Crazy that I didn't notice that before. Truly a crime on my end. Let's see how this looks when we add the waves back in. Probably a lot better. Who would have thought? I mean, yeah, it looks like proper sort of reflections again. You know. Actually, I'd like to go into my water waves and just make them chill out for a minute again. There it is. I'm honestly surprised that I didn't notice all that before. But I did now. Yeah. And here you can see that the Irradiance cache is missing a lot, right? Because normally you would see the GI and the reflections, obviously, and currently you don't, and that looks a bit funky because of that. There it is. Right. Very cool. I do want to say though that currently the way this looks, it looks very saturated and kind of contrasty. That is purely because of some tone map settings. So we go into the user settings, which is where you would set those parameters. You know, I was doing a 20% increase in saturation and a 10% increase in contrast. And so this is what it would look like without all those things in place. Right. Let's go to composite again for a minute. Yeah. So this looks a lot more like neutral. And it's great for artists when they want to work on textures. They can get it just right, and get it to look cohesive without being like thrown off by the color grading or anything. That's cool. Where is it? Just shadow.fsh, I think, yeah. Make those caustics a bit more exaggerated. Just like how we like them, right? Just how we like them. Oh. Whoops, my bad. Yeah, I mean, I don't know how to go about the water waves currently still, because they're kind of hard to deal with the parallax. See, this kind of stuff shouldn't be happening. I mean, obviously not, but anyway, I will leave them at their lower kind of amplitude. I think that looks better for the time being. And then the caustics can just kind of be less intense as well. That's another part about the caustics, which I do need to take care of, which is calculating them at different depths in the water volume. Right, and for the shadows, it's a bit more straightforward, I guess you could say, because it's just one depth per pixel, kind of, right? You can just bake it into the shadow map. But then the water volume, sorry, the water volume is using the shadow map to do the caustics. So those will have to be independent calculations from each other. And I don't want to recalculate the caustics at every step when I go and do the water volume. So I'll probably have to approximate that in some way. Which I think is fine. Just have to see, try to make it look as good as possible. I'll probably end up doing something like actually using the shadow map and then kind of fading them out as it gets more shallow to the water surface. Because I probably, no, I mean, I definitely cannot afford doing them at every step. That is just absolutely out of the question. So, yeah. Times a day. This glare, by the way, here, this is not the sun, this is just the volumetrics showing in the water reflections. I'm not actually rendering any sun disk yet. So that's that. Yeah. But I think I will re-enable the saturation and the contrast. does make things just look a little bit nicer. And these will be exposed to like users for them to adjust them how they want them. Of course, I'm not gonna keep those behind the code wall. I think I will just enable clouds, like the 3D ones. Just for the fun of it. And in all honesty, I might end stream soon. Or I might try, give it another go to the water issue we had at the start. But I'm honestly, it's not like we did nothing. We did fix the water reflections. We did some voxelization stuff. I'm pretty happy with that. You can really see how much the clouds add to the whole thing. It's crazy. Yeah, just balances it out. And yeah, I mean, optimization will be a big part of what's to come, and then TAA will clean up. We'll do all the cleanup work because it's definitely necessary. I'll just go back to where is it? Reveal? No, that's the files. Reveal active files and Explorer, and then yeah, I only need those in here so I can optimize this that way. I think I just might need to use a temporary buffer for this kind of work. Also, why does this look off, kind of? I think it's probably because the GI doesn't care for water extinction yet, or just generally. I mean, it is hard to do, probably. Not 100% sure how I'm gonna do that yet, because essentially, this kind of looks off because the water is taking away from the energy that the sand normally has in terms of lightness, right? It's like absorbing it. So looking at this, these trees are too bright in the front there. Right. That makes sense to me. Like from this kind of perspective, it all looks fine. But then if you pay attention to the... Yeah, like those logs here, this is way too bright looking. It's from the sand and all that. Right? If you look out, you don't really see any sand. or any dirt for that matter, right? It's just all covered up. And yeah, having some way to do that would be great. But I'm not there yet. Not there yet. So yeah, I'll employ the water extinction for now, but I think I have a decent way to go about it when I do. Yeah. Actually, one thing that I have been wanting to do for a while now is improve my subsurface BRDF, because I'm still using an outdated BRDF. Could be doing that. How about we just take a look at the current subsurface BRDF? Because I feel like there's a lot of stuff that I could be doing there and improving there. And I think I was procrastinating on it, like, for way too long now. This is my subsurface BRDF or diffuse. Let's see. We got the interface transmission here, and then we're mixing that based on roughness, and this is some sort of average, I guess. What's rough K? I forgot. Is it in the utils? Probably, right? For now, rough K. Vernal correction of highly reflective and rough Hammond materials. So this is the exact one. Okay. Let's see what's happening here, yeah. So it's essentially a smoothed out version of the interface transmission. So basically, I think it's the average overall angles, but I might be wrong, obviously. Where is it? There. That's fine for now. That's not great, but it's fine. So here we got the microfacet BRDF, which is not true by definition. This is not microfacet anymore. And this is some sort of correction factor here, it seems. All right. So this is trying to approximate what I'm doing now with H functions. Only problem, I need, like for H functions, in order to use those, I need the scattering albedo of the material. And that would normally not be a problem. I can just calculate it within that function. It's not great optimization wise, but I could do that. But then I don't believe the BRDF is not multiplied by albedo at all. It's being multiplied either here, which I don't think it is, right? Calculate the diffuse lobe, or much more likely is that I am multiplying the albedo in the defer program. So we got direct diffuse. This is what it essentially is, right? Calculate diffuse lobe. And then, yep. And I'm doing my subsurface magic on there. Fusion mask, convolve diffuse, blah, 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 blah. And then here, we're multiplying it by albedo. That's fine. If we were to use my preferred way of doing the subsurface BRDF, though, we'd have to add some additional logic there, right? So let's just see here. The best way to do this from a code cleanness perspective would be to just have a scattering albedo value baked into the material data struct that I'm passing around. That would be the better way to do it, right? So for subsurface materials, we'd have to calculate an additional value there, right? Yeah. So we could do that. Right, we have this subsurface thing going on here. So if subsurface not equal to 0, we do a calculate scattering albedo here. And yeah, I mean, I guess where are we? Yeah, let me just double check on this. We're using it a lot, quite a lot. Mostly in our BRDFs, obviously. Doing it here. Get voxel material data. Material unpack lab PBR. I don't actually know if that's the best way to do it, but it might be. So let's add a vec3 row. I think that's what it would be, right? Let's try it without it first. Actually, let's try it without it first, because I don't want to pass around too much data all the time. Starts in deferred. We get the material. So why am I doing that? Am I even using roughness? Like that roughness? I don't think I am. Just messy code. Go away. There. That's good. Material. Right. Now this is the has SSS. Boolean. This is what we should base it on, I guess. I guess I could pass in the scattering albedo into here. This has the has SSS thing. Actually, in that case, let me do it this way. So you have both of these get if has SSS, right? And then what we'll just do is, I think we have it in here where we have the get single scatter albedo function. And this could go into the H function related include. So I wouldn't be mad about that. Let's do that. We'll put it in here. Or actually, we could just make a separate include for it. Right? So actually could just repeat it as well. Does this have any top includes? Does. Okay. Oh yeah. Yeah. Here, I made my own specular distribution at some point. And it is energy conserving, it's just I don't think it's as easy to sample as the GGX one is. I might try at some point, but I honestly don't know of any important sampling routines that work as well as the GGX one. Like the VNDF is just kind of the best there is, in my opinion. Or that I know of, right? Feel free to prove me wrong. But yeah, okay, so fuse low subsurface. Okay. Well, let me for now see what do I do now? There. I copy this over to here. Will this cause problems? Probably will, let's be honest. Yeah. Knew it. Called it. Okay, so we could just make a could make another file called volume, or I mean, what would be the right word for this? Scattering properties, maybe, right? And then we could go from here, compute volume scattering properties, diffusion scale. There it is. Right, if we get all of that, put it in here, and then we include it. Include slash lib slash fragment slash bxdf slash bxdf lib slash scattering properties. Scattering property. GLSL, there we go. We do want to make this safe though, so if not define include scattering properties, then we define it. And then we end that off, right? So this can't be included twice, essentially, is what this does. And so we'll include it here, and we will also include it in the BRDF one. Okay, so now the pack works again. And we will also have to access the H functions in this one. So there it is. Okay. So that's a good start. Now diffuse subsurface, or here rather, this will need the additional, or will it? Actually, will it? No, not really. Because this will always be a diffuse material. So in theory, I go row, and this will be get single scatter albedo. Yeah, there it is. Get single scatter albedo, and we pass it in. So from the visual sort of albedo, it generates a single scattering albedo sort of yeah, number. So it works just fine. And if we replace this with, actually material albedo isn't being used here at all yet. That's slightly concerning. Anyway, basically we'll use the H functions then, or rather an approximation thereof, to replace this K factor here. So at the very least K smooth, but probably more than just that. So we'll have K equal to, and yeah, now it's gonna be a Vec 3, so let's actually just replace this all together. And then we'll pass in row and n.v. And let's see how this looks now. I think this probably saturated foliage. Seems slightly brighter too. Oh wow, okay. Something fishy is going on here. I think we might need to do this then. Or possibly even this. Yeah, there it is. Okay, so if we don't do this correction factor at all, let's see what it looks like. There. A bit dark, right? And that's just how it looks if you try to do a subsurface the RDF, right? But what you do essentially is you have the phase function multiplied by 4, and then you have this this denominator here, and that kind of gets it to behave correctly, but it also gets rid of all your energy. And adding this factor back in kind of conserves the energy again. At least tries to. Now this also saturates the foliage. So essentially, I think how this works is we I mean, let's check here. Let's put that back there, and then the deferred one here that needs to use the scattering albedo as well. Otherwise, we're falsifying our look. So, volume scattering properties. We get sigma t, the diffusion scale, but not the okay. I guess it's not outputting the single scattering albedo or row for that matter. Let's see where we use it. We use it twice. Okay, that's easy enough. Then let's add row. Row. And here as well then. And in here now, we add an in-out like 3 row. And replace this. Constant cannot be out parameter. Why is it a constant? Excuse me? Too few parameters in function call. Oh. That must be it. Oh, there you go. So let's try to multiply this here. Okay. So then also everything else probably looks very sad now. Using the single scattering albedo rather than proper one. Right? Or does this not change at all? I'm actually kind of curious. Doesn't change much. Interesting. Anyway. Oh, that's because... Yeah, duh. So this definitely uses row. But this currently still only does it where the diffusion mask is being applied. I don't want that. Go back to BRDF, and I think we can remove this times 4, and then it should be the right intensity, so to speak. I think this is it. Just remove this for a minute. Third one. Yeah. I mean, the back, it's just ambient, so that just uses the normal albedo. Yeah, I think this should be it. Let me just Check a different world. Right, this was the one that made my PC crash at the start of the stream. Okay. You can see it's very bright on the edges now. So let's go into the BRDF. And just, oops. Make these all vec 3s. Whoop.